Hi, my name is AMAL THURAYYA binti ABDUL with metric number AE180005. Today I'm going to present about introduction. A direct current motor is any class of rotary electrical machines that converts direct current electrical energy into mechanical energy. A DC motor consists of a stator, an armature, a rotor, and a commutator with brushes. Advantage of the DC motor is that it can develop a constant torque over a wide speed application. This project is mainly concerned on design and implementation of bidirectional DC motor position control system by using MATLAB. In this assignment, we simulate the plant of DC motor by applying Newton's second law of motion with the D'Alembert principle by implementing P, PI, PD and PID controller as a controller of the system on MATLAB. This is to compare which controller works best as a controller of the system.
Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is MIEZA SYAMIMI binti AHMAD SHUHAIMI and my metric number is AE180042. Now, I am going to explain about our methodology part. So, we are assigned to simulate the plan of DC motor with the given state unit and input voltage. So, firstly, we need to design the block diagram in the MATLAB software in order to generate the output. So, we did some research and findings on the internet about the design of the block diagram of the DC motor. So, throughout this research, we found several designs of block diagram that we can do as our references. Besides, we also need to implement the P, PI, PD, and PID controller as the controller of the system. So, to gain more understanding about this controller, we did more research, especially on this topic. And since we are still on ODL or online distance learning, we are unable to meet and do the meeting. So, we use Google Meet to discuss and change our knowledge and opinions on how to design this DC motor. Next, for the software, we did some try and errors to get us familiar with the system. We also asked opinion from the seniors that have already taken the subject previously to gain more understanding about this assignment. That's all from me. Thank you.
Assalamualaikum Doctor. My name is Salimah binti NASIR. I would like to show the result and analysis for PBL project. This is the coding that I have run. Right now, it's running. And the step for final value at step in final value is 0.8. Okay, now I want to show for the waveform of X. This is waveform for X, and now I want to show the P and also for tune, manual and auto for waveform for P. Now I want to change in PID controller to P. So I apply it. Okay. Now I want to tune the P controller. Sorry. It also take time. Okay, now it has shown the result for tune, so we have to wait for a while. Okay, this is a tune response, and now I want to change the response time to 5, so we will see the change of P. This is the new waveform after we change time P. So I want to show the parameter. This is for the parameter. And now I want to go for manual. VM, what is the waveform? Just click run. For X1, okay, VM, X, and X1. This is the X1 and X and VM for manual for P. Okay, now I want to change the PD, so I have to apply it. Okay, and then I want to show for the tune. Yeah. Okay, now we have to change the time response to 5 and update the block. We have to change the parameter, show the parameter, and this is the overshoot, and so on. For PD, this is the waveform that we get. Now I would like to show the waveform in scope. For VM, this is for X and also for X1. Okay, this is VM, X and X1 for the manual waveform. Now I want to change to the PI, apply it. Okay, and after that we have to tune. You have to tune for PI to see the waveform. This is the waveform for P. Now I have to tune for P. See the waveform. Okay, this is the waveform for P. I changed to 5 and now update the block. This is the 5 after I change the time response. Now I will show you the overshoot. This is the overshoot. If we want to change the overshoot less than 10, we can just use the transit behavior, so we get overshoot 9.3%. So now I would like to show the manual. This is for VM. Now I want to show this is for X. This is for X1. This is for VM. This is for X. I want to show the PID. Okay, for the last one is PID. So I want to I have done for apply, and then I want to show the waveform for PID, and now have to wait for tune. This is the waveform for PID. Now I want to change the time response. Update the block. This is the waveform for PID. This is the waveform for PID. And then I want to show the parameter. So if we want to overshoot, we have to transit behavior this. I have only get this 10.4%. So now I will show you the manual. This is the waveform for VM, and also this is waveform for X, and this is for X1. Now you can see this is for VM, this is for X, and combination for VM and X, it could be like this one, X1. That's for me. Thank you.
To conclude, a PI, PD and PID controller was inserted into a system of DC motor to see which one of the system creates a linearized system. The simulation was done for the system with and without controller. The response characteristic of DC motor improved with PID controller. The optimal values for controller parameters are obtained by the mathematical model of DC motor that includes applying Newton's second motion of law together with the Alembert principle, the equation of motion of DC motor. The simulation results proven that PID controller compared to other controllers which designed by changing control parameters value is an easy tuning and more effective way to enhance stability of time domain performance of the DC motor system. It is recommended that PID controller is to be used in closed loop system for a better linearized system and easy tuning performance in creating an object or a system. This is because PID controller is vastly used to control 2 or higher order plants, which results in fast transient response and zero steady state error that is desired for closed loop system. Thank you.